Good morning, students. This is Aalok Guptaa, your mathematics mentor and coach. So, I am on a mission where I want to actually uh, remove the fear of mathematics, the most feared subject among students and most disliked subject among students. If they start liking it, I will try to help them to excel in their lives because uh, knowingly or unknowingly, we do not understand the importance and the application of maths in day-to-day life, and that's one thing which makes students run away from mathematics, are afraid of mathematics. So I will be doing a series of lectures which it will be available to you uh, free of cost on YouTube channel. So the first topic which I'm touching is trigonometry. So there will be a series of videos where I'll be doing the trigonometry lectures right from 9th grade, 10th grade, 11th grade, and 12th grade, uh, ISC, ICSE, SSC, Cambridge A level, all the trigonometry issues, all the trigonometric problems that normally a student faces, you will be able to understand them in much more clarity. Uh, I will start with basically why trigonometry. Why trigonometry was born, why it was necessary for the world uh, to discover or invent trigonometry. First of all, let us understand what trigonometry means. Trigonometry simply means measurement of angles. So classically, it started with measurement of angles with triangles, but then it can be applied to quadrilaterals also, polygons also, and circles also. Uh, any shape we can apply the trigonometry, because each of these shapes can be further divided into triangles, multiple triangles. So we can apply the formula, we can apply the concept of trigonometry to all these shapes. Why it is necessary? See, if the most important application of trigonometry is that if you want to locate, if I'm saying there is a space and I'm representing here the coordinate axis x and y, if you want to locate any particular object in the space, then by taking from a reference point, and there is an object here, then by basically identifying or measuring this angle, it will help me to specify or to find the location of that object. So like in defense systems at times of war, when the enemy is firing missile on your city or a country, uh, with the concept of trigonometry, a lot of other concepts also are involved. You can actually intercept the missile and try to hit it and try to diffuse it off in the air itself. So that is one of the biggest application in space technology. In when you're sitting in an aeroplane and in the control room, you exactly know the location of where exactly the plane is flying. So all these are basically the applications of trigonometry, heights and distances. You want to find the height or distances of so many things that are day-to-day application in construction industry, in infrastructure. So it's a huge amount of application of trigonometry. So in future, maybe some of you students might be in some of these industries and trying to work at a different levels. So this knowledge of trigonometry really helps you in a very thriving career, and specifically when you've passed 12th grade and you have to enter into your dream university by giving some entrance exams. You want to do BTech, or you want to do a certain MBA programs. So trigonometry also is one of the subjects by which you have to pass through during those entrance tests. So it helps you to basically find your dream university and then grow in life. So please do not try to avoid this important topic, because trigonometry is the major component as far as mathematics is concerned till 12th grade. Very important part of calculus. So please try to understand it. I'm trying to make it as simple as easier for you guys. So let's start. So having understood that, let us first understand trigonometry. Uh, what does it say? So I'm trying to draw some right angle triangles. So in this lectures, in couple of lectures, I'll be covering only 9th grade ISC right now. So ICSE. So basically, I'll be talking about only right angle triangles. We'll apply trigonometry ratios in right angle triangles, and after that we will scale it up to any other triangle, any other angle, 135, 120, 210, 315, 360. So as and when we grow in 11th grade or 12th grade, we'll try to apply trigonometric ratios and try to find the trigonometrical ratios of angles greater than 90, greater than 180, greater than 360, and so on. So let us say this angle is 30 degrees. I'm drawing, let us say this, I will call it as a side perpendicular. This I will call it as a base, and this I will call it as, this is hypotenuse. Okay. Now I will draw another triangle in which I will keep this angle same 30 degrees. But now I have changed this height, this perpendicular. I will call it as P1. I will call it as B1, and I will call it as H1. So in this both these triangles, when I take a ratio, in this triangle, when I take a ratio of P upon H, and in this triangle also I take P1 upon H1. Interestingly, it was found as long as this angle remains the same, these two are equal, and that's how powerful the trigonometry became. Which means, and this function P by H normally is known as sine function, which I will explain it to you a little later. Same way, in this triangle, if I take a ratio B upon H, this upon this, and in this I take B1 upon H1, again they both are the same as long as this is 30 degrees. So both angles are same. Same way, in this triangle P upon B, this upon this, and in this triangle P1 upon B1, these two are going to be same. So that's what basic reasoning behind or understanding behind a trigonometric ratio. Now let us, having understood the application of trigonometry, having understood how important it is for mathematics students, and let us start defining those ratios. So let us say I call this triangle as A, B, and C. So normally these angles will refer it with certain notations, like this is alpha, this is beta, this is gamma, this is theta, this is phi. So alpha, beta, gamma, theta, and phi. So you will hear such kind of angle measurements. So normally I would like to use theta, correct? And this is 90 degrees. This is a right angle triangle, which primarily we are going to learn in 9th standard, in 9th grade. So if, and we will always refer to this side, which is as perpendicular side. This I will always refer as B, and this I will always refer as hypotenuse, which is H. And one thing we always use is Pythagoras theorem, which everyone knows. This is what we are going to use very often in trigonometry. So there are basically 6 trigonometric ratios, basic ratios which are defined, and they are known as sine, cosine, tangent. These are the 3 basic, and reciprocal of sine is known as cosine, cosecant, and reciprocal of cosine is known as secant, and reciprocal of tangent is known as cotangent. That's it. Everything is revolving around this. And what are this? So these are basically like you have exponential functions, logarithmic functions. Same way it is trigonometrical function. So what is the basic definition of all this? So sine is always of an angle. So here I will remove the sign of an angle theta. Correct? It is always defined as the side opposite to theta, that is P, ratio of sine opposite to theta upon hypotenuse. This is the basic definition of sine. And what is the definition of cos? It's basically the side which is adjacent to this angle, whose cosine you want to remove, that is B upon H. And what is tan theta? It's a function which is the side opposite to this angle, which is AB, T upon side which is adjacent, that is B. So these are the basic definitions of sine theta, cos theta and tan theta. Now, since cosec theta is a reciprocal of sine theta, we'll call it as H upon P. Sec theta is a reciprocal of a cosine function, so we'll call it as H upon B. And cot theta is a reciprocal of tan function, we'll call it as B upon P. So now we have understood the definition of all 6 trigonometrical ratios. Now, having understood this definition, we'll try to find out, or we'll try to do certain numericals. Let us try to understand. Let me go to the exercise straight away. We'll understand the application with those exercises. So exercise 22A. Now, let us try to see this first question. From the following figure, find the values of sine A, cos A, cot A, sec C, cosec C and tan C. Correct? So, what is the triangle? This is the triangle. This is right angle. This is 4. This is 3. This is A. This is B and this is C. Now, this is the angle A. So, what is sine A? Okay, first of all, let us try. We'll always need the hypotenuse. So, since it is a right angle triangle, I can find AC by using Pythagoras theorem. AC square is 4 square plus 3 square. So, AC square is going to be 16 plus 9, which is going to be 25. So, AC is going to be square root of 25. I'm only taking the positive value because it is representing the side. So, it is going to be 5. So, by definition, what is sine A? Sine A is opposite side to this angle. So, A angle opposite side is BC. So, 4 upon hypotenuse, which is 5. So, sine A value becomes 4 upon 5. Similarly, what will be cos A? Cos A by definition is the adjacent side to the angle A upon hypotenuse. The adjacent side is 3 and hypotenuse is 5. Then cot A. So cot A is nothing but reciprocal of tan A. Okay, and what is tan A? Tan A is opposite side upon adjacent side. So 1 upon 4 upon 3. So this will become as 3 upon 4. Then we have to find sec C. which is 1 upon reciprocal of cos. And what is cos? Cos of C. Cos of C is adjacent side to angle C, this which is this, upon hypotenuse, which is 1 upon 4 upon 5, which is 5 upon 4. Then we need to find cosec C. Cosec C is what? Reciprocal of sine, 1 upon sine C. And sine C is what? Opposite side, which is 3 upon hypotenuse, which is 1 upon 3 upon 5, which is 5 upon 3. Then finally we will ask tan C. So by definition, what is tan C? Opposite side upon adjacent side. So 3 upon 4. So with basic definition, we have tried to understood, we have found out the trigonometrical ratios as asked in this sum. Correct? So now we go to the second sum, which says from the following figure, find the values of cos B tan C sin square B plus cos square B sin B cos C plus cos B sin C. So we have been given a triangle like this. This is 90 degrees. This is B. This is C. This is 17. This is 8. And first we have to find cos B. So cos of which angle? I have to find cos of angle B. So now if you see, this is the hypotenuse because 90 degrees is here. Side opposite to 90 degrees is always hypotenuse. To find cos B, I need to know this side and this side, which is okay for me. So I can directly find as adjacent side. The side adjacent to cos is 8 upon hypotenuse, which is 17. Now second, we have to find tan C. Now to find tan C, which is this, I will do side which is opposite, which is 8 upon adjacent, which is AC. But I don't know AC. But since this is a right angle triangle, I can find out AC because I know by Pythagoras theorem AB square plus AC square is BC square. So AB square is going to be 8 square. AC square I need to find out. And this is 17 square. So 64 plus AC square, square of 17 is 289. Then AC square becomes, the 64 goes on that side. So 289 minus 64. 289 minus 64 is 225, which can be written as 15 square. So AC becomes 15. So this side is 15. Correct. Now I need to find tan C. So tan C would be opposite side AB upon adjacent side AC. So 8 upon 15. Then what I need to find? Sin square B plus cos square B. So let me find sin B. So sin B is opposite side upon hypotenuse. Opposite side is AC, hypotenuse is BC. So 15 upon 17. And I will square that because it's the square of sine. Cos square B is adjacent side upon hypotenuse. So 8 upon 17. 8 upon 17 square. So this became 15 square is 225. 17 square is 289, 8 square is 64 and 17 square is 289. So 289 is common, 225 plus 64 is 289, so answer is 1. So this answer we got, this we got, this we got. Now finally we need to find out sin B cos C plus cos B sin C. So we'll try to find out individually what is sin B. By definition, opposite upon hypotenuse, which is 15 upon 17. What is cos C? Cos C is adjacent upon hypotenuse. This is adjacent, this is hypotenuse, 15 upon 17. Cos B. What is cos B? Cos B is adjacent upon hypotenuse, which is 8 upon 17. And sin C. What is sin C? Opposite upon hypotenuse, which is again 8 upon 17. So this will become 15 square upon 17 square. plus 8 square upon 17 square, which is 225 upon 289, plus 8 square is 64 upon 289, which is 289 upon 289, which is 1. So now we could find all the things. Let's try to move ahead. So I'll try to. So now let us try to solve a different type of sum. Let us go to sum number 4. From the following figure, find the values of sine b, tan c, sec square b minus tan square b, sine square c plus cos square c, and this is the figure which is given to us. So let's try to solve this. So this is given as 13, this is 5, this is 16 units, A, B, C, and this point is D. Correct? Now we have to find sine B. So typically in this kind of sums, what we should do is we should first calculate the values of all the sides. So because we are going to require to have all the sides, we should know, because in some part tan A, cos A, or whatever has been asked, tan C, sin B, we'll need those sides. So if this is 90, this entire thing is 180, so this also will be 90. Now this is a right angle triangle, so we'll apply Pythagoras to triangle ABD. So in ABD, I can say, let us say AD square plus BD square is AB square. So AD square I need to find, AD I need to find. BD square is 5 square and AB square is 13 square. So AD square will become plus 25 is 169, 13 square is 169. So AD square will become 169 minus 25, which is 144. So AD will be square root of 144, which will be 12. So this side is 12. Similarly, now since I got this side, I will apply Pythagoras in triangle ADC. So here it will be AD square, which is 12 square, plus CD square, which is 16 square, equals to AC square. So this will be 144, 12 square, 16 square is 256, is AC square. 144 plus 256 is 400, which is AC square. So square root of 400 would be AC. So AC becomes 20. So this side is 20, right? Now let's try to find out what have been asked. Sine B, so what is going to be sine B? Sine B is going to be opposite upon hypotenuse, to side opposite to sine B is AD, hypotenuse is AB, so 12 upon 13. Then tan C. So what's going to be tan C? This is tan C. By definition, what is tan? Opposite side upon adjacent side. So opposite is AB, adjacent is DC. So 12 upon 16, which we can further do it as 3 by 4, divided by 4, both the sides. Then next is sec square B minus tan square B, which I will write it here. Let us say sec square B minus tan square B. So what is sec square B? So sec square B is opposite of cosine. This is B. Cosine is what? Adjacent upon hypotenuse. So sec will be reciprocal of cosine, which will be hypotenuse upon adjacent. So 13 upon 5 square. Understood? And tan square B is what? Opposite upon adjacent, that is 12 upon 5 square. Correct? So this will become 169 upon 25. This will become 144 upon 25. 25 is common. It's the LCM. 169 minus 44 is again 25. This is 1. So we could find this also. this also, this also. Now we've been asked sine square c plus cos square c. So sine square c plus cos square c. So let us try to find out. So sine c is what? Opposite upon hypotenuse, which is 12 upon 20 cos square. What is cos c? Adjacent upon hypotenuse, that is 16 upon 20 cos square. This will become 144 upon 400. This will plus 16 square is 256 upon 20 is 400. If we add this, will become 400 upon 400. So this also is 1. So we could find given this. Understood? Let's try to go to the next sum. So let's try to go and try to solve a sum which is next. Let us take an interesting sum. So let us try to take question number 7. Now here, like in other sums, you have been given the triangle and you are given the sides, and you are supposed to find the trigonometric ratios. Now here, I think they have asked it in a different manner. So yeah, in this sum, what we have been given is cos A. You have been given the cosine, the trigonometrical ratio values. It's 5 upon 13. And you have to find the values of sine A minus cot A upon 2 tan A. So that is first one. So let us try to understand this. So what we will do is, since we are talking about right angle triangles, I will draw a right angle triangle. Okay? And I will name it as A, B and C. Now cos A, the value of cos A is given to me. So this is the angle A, and cos A by definition is adjacent side, which is AB, upon hypotenuse, that is AC. Correct? Now, which is equal to 5 upon 13, which means this should be 5 and this should be 13. Correct? Now this is a right angle triangle, which means AB square plus BC square is AC square. So AB square is 5 square plus BC square, and AC square is 13 square. So 25 plus BC square is 169, which means BC square is 169 minus 25, which is 144. So BC becomes square root of 144, which is 12. Correct? Now I have to find out sine A minus cot A upon 2 tan A. So let us say, what is sine A? Sine A is opposite. Now this is 12. Opposite upon hypotenuse. So this I can put it as 12 upon 13. And cot A. Cot A is reciprocal of tan A. Tan A is opposite upon the adjacent. So cot A will become adjacent upon opposite. So this will become 5 upon 12. Now 2 tan A. So 2 will still remain 2. Tan A will be 12 upon 5, opposite upon adjacent, 12 upon 5. That's what been asked with us. Sine A minus cot A upon 2 tan. So sine A is 12 upon 13. Cot A is 5 upon 12. 2 into 12 by 5. Correct? So now this will be 144. This will be minus 65. This will be 13 into 12 upon 24 upon 5. So this is how it became. So let us understand. So 144 minus 65. Let us understand 144 minus 65. This will be 9. This will be 7. 79. So this became 79 upon 13 into 12 into, now divided by 24 by 5 means multiplied by 5 by 24. Correct? Now you have to simply multiply this and find the answers. So 79 into 5. 5, 4, 35, 395, and this will be 395, and 13 into 12, 3 to the 6, 2, 3, 1, 6, 5, 156, and 156 into 24, 4, 2, 22, 2, 4, 1, 4, 6, 24, 12, 1, 10, 11, 1, 2, 1, 3, 4, 4, 7, 3, 3, 7, 4, 4. So similarly, you can find cot A plus 1 upon cos A also. So I'm not doing that part. I will rather take some other question. Let us try to do this one. If sec A is root 2, if sec A is root 2, find the value of 3 cos square A plus 5 tan square A upon 4 tan square A minus sin square A. Correct? So again, when we have been given a trigonometric ratio, and let us try to construct a right angle triangle. So I'll construct a right angle triangle. I will name it as ABC. Now sec A, I am given secant A as root 2. Now what is the definition of sec A? Hypotenuse upon adjacent side, right? Because it is the reciprocal of cos. Cos is adjacent side upon hypotenuse. So it will be hypotenuse. So this is root 2 upon 1. So it will be root 2, which is the hypotenuse, upon 1, which is adjacent, which is this. Now I got this. I can find side BC by BC square plus AB square is AC square. So BC square, BC I need to find, AB is 1 square and root 2 square. So BC square plus 1 is 2. So BC square is 2 minus 1, which is 1, which means BC is 1. So this is 1, correct? Now I'll simply find these values. 3 times of cos square A. What is cos A? Adjacent side, which is AB, upon hypotenuse, which is 1 upon root 2, square of that, plus 5 tan square A. Tan is A, what? Opposite upon adjacent, 1 upon 1, that is 1 square, upon 4 tan square A, which is again 1 upon 1 square, which is 1, minus sin square A. What is sin A? Opposite upon hypotenuse. So 1 upon root 2 square. Correct? So this will be 3 upon 2 plus 5. This will be 4 minus 1 upon 2. Which will, when we simplify, 5 into 2, 10, 10 plus 3 is 13, 13 upon 2. 8 minus 1 is 7, 7 upon 2. This gets cancelled. Answer is 13 upon 7. Understood? So if you see, this exercise typically is associated with finding either a trigonometrical ratio when sides are given, or if trigonometrical ratio is given, how to find the other trigonometrical ratios. So, or any expression, the value of any expression like we did in this sum. Let's try to do some more. I can see something here which is, the actual values are not involved, but they are given in terms of P and Q. So let's try to solve that. So they've said sine theta is P upon Q. And we have to find out the value of cos theta plus sine theta in terms of P and Q. Very simple. We are again trying to construct a triangle, a right angle triangle. Let us say this angle, I will take it as theta. Sine theta is P upon Q. So sine theta is opposite side, which is P, upon Q, which is hypotenuse. Now let us say this triangle is ABC. Now I will need this side also. I will apply Pythagoras theorem. BC square plus AB square, which is P square, is AC square, which is Q square. So BC square becomes Q square minus P square, which means BC will become square root of Q square minus P square. Correct. So this became square root of Q square minus P square. Now I need to find value of this. So what is cos theta? Cos theta is adjacent upon hypotenuse. So adjacent is Q square minus P square upon hypotenuse. And sin theta is opposite upon hypotenuse, which is P upon Q. Now I can, LCM Q is same, denominator is same. So I can write this as square root of Q square minus P square plus P. Or better way of writing is P plus square root of Q square minus P square upon. Okay. So let's try to do one last sum. Let us try to take 20th. I think that looks like an interesting sum. So let's try to see AD is perpendicular. AD is perpendicular to BC. AC is 26. CD is 10. BC is 42. Okay, so let's try to draw that diagram here. So this is ACB. ACB. And then there is a perpendicular altitude which goes here. This angle is given as X and this angle is given as Y. And AD is perpendicular to BC. AC is 26. So this length is 26. CD. So CD, this length is 10. BC. So this entire length is 42. Very good. And DAC is X and B is Y. Find the value of cot X first. So let us first try to find cot X and then we'll find remaining ones also. Okay, so what do they say? So this is 26, this is 10, and this entire is 42, which means this BD will be 42 minus 10, which is 32. So there we got it. Now we don't know these two sides. So I will try to find these two sides. I will apply Pythagoras theorem in this triangle ADC, and then I will get this side. So when I apply the Pythagoras theorem, I can apply as 10 square plus AD square is 26 square. So 10 square is 100. AD square, 26 square is 676. So if I take 100 on that side, AD square will become 676 minus 100. So AD square will become 576, which means AD will become square root of 576, which is nothing but 24. So AD I found out, which is 24. I got this. So I got this AD as 24. Now this is 24, this is 32, and I need to find AB now. So let us find out. So in this triangle ADB, I can write AD square plus BD square is AB square. Correct? So AD square is 24, so 24 square, BD square is 32 square, and AB I need to find out. So this is 576, 32 square. If someone doesn't remember, just simply do this 1024 is AB square. If I add these two, I add 576 to this will become 1600. So 1600 is AB square, which means AB is square root of 1600, which is 40. So I could find AB also. So this AB is 40. So now I got all the sides with the information I was given in the sum. Now I want to find cot x. So cot x. So cot x is nothing but adjacent side upon opposite side. What is the adjacent side to cot x? AD, which is 24, and opposite side is DC, which is 10. So I can say 12 upon 5. So I could find cot x. What is next? 1 upon sine square y. 1 upon sine square y minus 1 upon tan square y. 1 upon tan square y. Okay. So let's try to find that out. So sine square y. So sine y is this. So sine y is what? Opposite side, which is AD upon hypotenuse, that is 24 upon 40 the whole square. So I can write 24 upon 40 the whole square minus 1 upon tan square y. Tan y is what? Opposite side upon adjacent side, that is 24 upon 32 square. 24 upon 32 is the square. Okay. Now, if I have to correctly do that, so I will do 1 upon 24 upon 40 square minus 1 upon 24 upon 32 square. This was what I wanted to find out. So I can take 40 square up. I can put 24 square here. I can take 32 square up and I can put 24 square here. Okay. Now this is 1600. 24 square is 576. 32 square was 1024. 24 square is 576. So this becomes 576 upon 576, because 1600 minus 1024 is 576, which is 1. And finally, we've been asked 6 upon cos x minus 5 upon cos y. 6 upon cos x minus 5 upon cos y plus 8 tan y. Minus 5 upon cos y plus 8 tan y. So we'll simply put what is cos x. So cos x is adjacent upon hypotenuse, which is 24 upon 26, because the adjacent side is AD, hypotenuse is AC in this triangle. So 24 upon 26 minus 5 upon cos y. What is cos y? Adjacent 32 upon 40. 32 upon 40 plus 8 tan y. What is tan y? Opposite upon adjacent, 24 upon 32. Opposite upon adjacent, which is 32. 24 upon 32. Correct? Now this I can cut with 4. 26 can go up to 26 by 4. 5. No, I will cut 32, 4 and this 5. And 5 can go up, which will become 25 upon 4. 8 I can cut with this as 4. So this will become 24 upon 4. So I can put 4 as a common. 26 minus 25 plus 24. So that is 25 upon 4 is the answer. Understood?